Hello guys, hi internet. This is the first recording um, to chronicle the progress that I've made on my projects. I started my project about a few months ago in April. I suppose the first commit is in April. By the way, so this on the left hand side is my GitHub page. You can get to it via https://github.com/Morpheus. Just replace the alphabet R with the number 3, so it's mo3 Morpheus, because somebody obviously had taken Morpheus on GitHub. Otherwise it would be a shame to the character and the programming community in general. But okay, regardless, moving on, I have about 12 repositories that are publicly available here. The repositories of interest to this recording and the series of recordings that I've started to chronicle my project. The series is called Out of the Blue and Into the Black. If you want to know what that is, you have to read my article on LinkedIn and figure out what the hell I'm talking about. But the repositories of interest to this series are going to be MarsRover and MissionControl. I guess the Storm client for MarsRover is also relevant here, but I'll see if I can get to that. There is quite a lot to do just between these two projects. So okay, without any further ado, I have downloaded and built these two projects, obviously, me being the creator of them, but you would have to, if you want to contribute code to this project. I will set up detailed installation instructions on how to get started. Today was the first day that somebody other than me downloaded and tried to run this project, and it exposed a lot of flaws, a lot of hard-coded paths and so on that I have to fix in order to make the process a bit more seamless. So okay, enough of the rambling. Let me give you an idea of what to look for here. So on my screen I have two terminal windows, well actually many terminal windows open, but split into two areas. The left half is gonna deal with the rover, or the simulation of the rover that I've created, and the right half is gonna deal with mission control, or our command and control station for the rover. So without any further ado, let's actually start mission control. Okay, so there was already maybe a couple of messages that were lurking around on the Kafka queue, which is what we are receiving here, because we haven't even launched the rover yet. So okay, I realize that I'm jumping all over the place, please forgive me. Okay, so what am I talking about? The rover, which, let's just deploy that so it'll all of this will make more sense eventually, so hang in there with me, despite my apparent inability to communicate. Okay, so this is the 2D simulation of the rover. The black square here represents the rover, and the surface along with the grid lines represents the surface of Mars. The brown and dark brown cells here, which is think of this as the Lego version of a 2D top view of Mars. The brown cells represent obstacles, so your rover cannot bump into them or it would hurt itself and die. The blue is supposedly water, but anyways, that's not feasible on Mars, so we'll just assume that's dry ice. And if our rover gets there and discovers dry ice, then hurrah to us. The purple squares are actually locations of the previous rovers. Obviously, this is an idea, like all great ideas that I have is straight up stolen from The Martian, the movie whereby Mark Watney actually drives himself up to Pathfinder and steals its radio. I'm gonna simulate that in software, but I'm not there yet. Uh, anyway, so that gives you an idea of what this is. So this rover and our command station here communicate with each other via Apache Kafka. Uh, to have that up and running, you need to have Zookeeper up and running, which is here. Along and here you can see Zookeeper in all its glory, its warnings and info and errors and all of that. This is the Zookeeper log. And here you have Kafka log, which is continuously bitching about some offset. I suppose this is not really an error message; it's just an info message that Kafka keeps on spitting out. If you change the logging level of the project to debug, then you will realize exactly how much Kafka can annoy you. But other than that, Kafka is actually pretty brilliant. It works straight up out of the box. If you have a Linux operating system, of course, or a Mac. If you have Windows, then um, yeah, whatever. Okay, so we relaunched the Earth client to listen to Mars one more time, and now it doesn't have any lingering messages in here. Let's finish our launch or the deployment of the rover itself. So when you launch the rover, it's going to tell you all the sensors are deployed, and then at some point it's going to ask you what is the username and password to authenticate to its MySQL database. You have an option through properties file. Let me show you that. Where is my properties file? Source main resources rover db should be the properties file. So in here you have the option to disable this. If you say mars.rover.database.log, which is the property.enable, equals false, then it's no longer going to insist upon you providing the authentication. So there's that. The demo key or the authentication key for the NASA API you should not skip, and you cannot really skip. I guess I've never really tried that. Maybe we should just try giving it a dummy key here and see what exception it throws up. But that's for a later date. Just type in demo key there and life will be better for you. Just trust me on that for now. Okay, so this is STD out from the rover itself, and you will realize shortly here that I'm writing messages to both STD out and a log file, which I suppose something is wrong with me for doing that. But anyways, that's one of many issues wrong with me. So we'll get to that later. But here, congratulations to us, is the first message we have received from the rover. So from this we can ascertain that Kafka is working as it's meant to, and that we are actually being able to use Kafka correctly to talk to Earth. We haven't tried talking back to the rover yet, so we'll get to that in a little bit. And if you're paying close attention, I apologize, the screen is extraordinarily huge here and the window of interest is rather small, so my apologies for that. But if you are able to pay attention, on the black dot you will see a tinier orange dot blinking, which does represent the rover transmitting messages. If that dot changes to a green dot, it's the rover receiving messages. It's supposed to send out a heartbeat once per minute, but since I've started talking, and maybe I'm talking too slow, it seems to be spitting out these messages much quicker. So I'm not quite sure what that rate is right now as of this moment. Um, yeah, it's definitely not a minute. It's much quicker. All right, that's going to be annoying to us. So let me kill this guy and relaunch it with the right settings. Okay, hang on. While I'm gonna do that, I'm going to gracefully pause this. Okay, so the kind of fixed the problem by not really doing anything, which is how I suppose most of our software bugs get fixed. Um, all right, so we were discussing what the rover does. Okay, here we go. So like I explained before, on the right hand side we have the messages being received from the rover, and on the left hand side we have the rover itself and who is transmitting the messages. Uh, Now in actual life there is a delay depending upon if you have line of sight, but regardless there is a delay between 8 to 12 minutes uh, from the time that you send a radio signal from Earth to the time that it actually gets to Mars. That's because light takes between 8 to 12 minutes to get from Earth to Mars, and that's as fast as your radio signal can go. Um, well, obviously on software we are not going to wait between 8 to 12 minutes, so I've time scaled that, and so the way that's represented here is that from the time a rover sends a message to Earth, it's going to be 8 to 12 seconds by the time the message is sent and to the time you actually receive it. And vice versa, if you send a command to the rover, it's going to be 8 to 12 seconds after the fact that it actually gets to the rover. So just bear that in mind. Alright, so I guess I'm going to utilize the rest of this time to explain to you the capabilities of the rover briefly. Um, um, and that will conclude our first introductory video, I suppose. Okay, so the rover operates itself mainly through a series of internal states. It The kernel of this rover, which is its operating system, is implemented through a state machine. And if you follow the Java state machine pattern or design pattern, you should have no trouble following the code and what it does. So at the moment where you can see the color going from black to white, the rover is in sleeping state. It goes into sleeping mode if you haven't talked to it for a while. So it tries to sleep in order to preserve its battery. When not in sleeping state, I suppose every 3 minutes, that's the config right now, every 3 minutes it's going to wake itself up and then transmit a heartbeat just to let you know that it hasn't really died. This on the right hand side, the highlighted portion, is the protocol buffer that represents the heartbeat of the rover. In it you get a snapshot of the capabilities of the rover itself. So you can see that it has a battery, it has a radio, it has LiDAR, it has a camera, a spectrometer, a radar, and the Mars weather station. It also has a telemetry sensor and propulsion unit, which aren't represented here, and maybe that should be a Jira or a bug to be raised. But okay, enough of one-way communication. Let's actually try to send a message to the rover and see what happens. To do that, I'm gonna go back to launching my command center. So this is a part of the MissionControl project, which comprises of the command center. So I'm going to ask it to move, and since my grid is 700 by 700, I'm going to give it a coordinate within that range. And because I know that each individual cell or one square within that grid is 25 pixels wide, I'm going to give it coordinates that are multiples of 25. Ideally, if I give it coordinates that aren't, which would make them illegal coordinates, I should handle it and I should return an invalid status of sorts. But while I was talking, we missed on the amazing part where the rover actually gets the message and starts moving. The animation for the rover here is developed in Java AWT, which is why you can see it blinking every once in a while. And I'm not quite sure how accurately or inaccurately that would be recorded on video. So that's something that I need to watch out for. But regardless, when it got that message, the rover exercised its navigation engine. And you have a couple of different options for the navigation engine. You can either use reinforcement learning, at which point the rover has to know where the walls are and then train by getting feedback from the walls as to whether it finds a reward or a punishment and so on. And it would actually learn the environment and the obstacles. Or you can use what it's using right now, which is an A-star algorithm in its nav engine, which obviously also entails obstacle avoidance by configuring the adjacency matrix accordingly. While it was moving, we have simulated a motion sensor on the rover. That motion sensor recorded the data, which I'm transmitting as telemetry data. Now technically, if you look at the actual definition, any data that comes from the rover to Earth is telemetry. Telemetry is just remote recording, but I've just chosen to use that word here to transmit the motion sensor data. What do we have as part of telemetry? You have the location, which you can see is changing from one message to the next. You have its velocity, which is how many units it moved on the grid per second. You have its heading, and because it's only going to do right angle turns, your heading is going to be a clean multiple of 90. So the heading was 270 here, and you have the distance traveled from its origin point. You also have SEET, which is spacecraft event time, which is the timestamp at which this was occurring on the spacecraft. So like I said, when you actually get the message, there would be a time delay. That would help you figure out exactly where the rover was at a given point of time in the past. So okay, with that I'm gonna conclude this video. There is a lot more capabilities to the rover, and in future videos we would exercise each of those sensors and see what message it transmits. And I'll also utilize the series of videos to go into the code and into the operating system to kind of explain what it is doing under the covers. But that's it for now. Thanks for, if you have waited this long to actually hear this message, or which means you have endured this video for so long. I genuinely appreciate it, and thank you.